Force and pressure.
Okay. You can see the screen.
Yes, sir.
So this is what we did last time, force and pressure, right? So in the end, did I say what is pressure?
So yes, sir.
What is pressure?
So
It's force acting on a unit area. Suppose this is the block, it has got weight.
yes, sir.
It has weight. So this weight acts on the surface below, right? Right? And it acts on the
Yes.
surface. It acts over an area which is equal to the area of contact. Take this length is L and this is breadth B. The total force is acting on the area L into B. Okay, so that force divided by the area, that is L into B, will give you the force acting on unit area. So the force
Yes,
acting on unit area is called pressure. Okay,
Yes, sir.
all right. So now we'll move to that today's thing. We'll do something a little bit different. I'll talk about friction. Okay, so what do you understand by friction?
So it's the contact force and acts between two surfaces when in motion, when one is in motion and touching the ground.
Yeah, so we can say it opposes
Direction of motion.
relative motion. Okay.
Yes, sir.
Okay. Here in the first picture, how does it look? What is the situation? It's a book, right? Book on the table or notebook on the table, and it's
Yes,
being
sir.
pushed. And it's being pushed. So the first one, the direction of pushing is what? Left to right or right to left?
So left to right.
The upright force direction is towards right. And
Yes, sir.
what is the direction of friction force?
Left.
Yeah, so it is opposing the upright force.
Yes, sir.
So in the second figure, the direction of applying the force is towards left, right?
Friction is right.
The friction is in the right direction. So the direction of friction force depends on the direction of the upright force. Basically, it opposes the relative motion.
Yes, sir.
The friction force is opposing the direction of motion. Okay, and can you think of some instances where friction force is required? Like
So for walking,
yeah.
so for matchbox,
Okay.
so some climbers need grip.
Right.
So brakes of a car.
Yeah, you apply the brake and then what happens? The vehicle stops, right? Okay, the vehicle stops because of friction between what and what?
So between the gear and the wheel, like the brake disc and the wheel.
Friction between tire and root. Actually, there are two things happening here.
Yes, sir.
Hold on. First is the friction between the brakes and you can say drum or disc. Okay, this will reduce the rotational speed. Rotational speed is denoted by the symbol omega. Rotational speed is denoted by the symbol omega. You know that?
No, sir.
Okay, so the disc is rotating and the wheel is rotating, tire. Okay, so that tire rotation speed has to come down, right?
Yes, sir.
That happens when you apply the brake. Okay, and after that the vehicle is translating. Okay, this is a car, it's moving in this direction. Okay, so first the rotation of the tire will get reduced because of the brakes. Okay, and after that this thing is translating with the velocity. So
Yes, sir.
even if the tire is not rotating, this thing can be moved. Like that's like sliding.
Yes, sir.
Okay, so that motion has to stop. For that to stop, friction between the tire and the road will act. So there are two things happening. First, you apply the brake because of the rotational speed of the tire is reduced, and after that, the translation speed of the car is reduced by the friction between the tire and the road.
Yes, sir.
Suppose there is no friction between tire and the road, it will keep on skidding,
Yes, sir.
even with the tire not rotating. Just assume that the tire friction between the brake and the disc is present. Okay, because of that the rotation of the tire is being stopped, but there is no friction between the tire and the road. So,
Yes, sir.
so the vehicle will keep skidding. That's what happens during winter on an icy road. The icy road, the friction between tire and the road is reduced, very, very small.
Yeah.
But the brakes and the disc will work because ice is not on that. Okay, so that's why the vehicle skids on an icy road.
Yes, sir.
Okay. So how can you increase friction?
So changing the roughness.
Yeah, you can increase the roughness of the contact surfaces.
Yes, sir.
Any other way?
So instead of rolling friction, do sliding friction.
Okay. No, that is for increasing. Increasing. So for increasing, you have to, yeah, what you said is correct. So rolling should be converted to sliding.
Yes, sir.
And anything else?
So making grooves like the soles on wheels.
Yeah, that is fine. That is equivalent to surface roughness, right?
Yes, sir.
What about something very different? What about weight?
Yes, sir.
If you increase the weight, friction will increase. Friction force will increase. If friction force is given as mu into normal reaction. Okay. What is mu?
Yeah.
Any idea? It's a constant. Depends on the surface. Okay. And n is a normal reaction. Okay. So if the mass is like this, okay, then what is the value of normal reaction? Is moving like this with some velocity v. What is normal reaction in this case?
So N.
Yeah, but that is equal to so n will be equal to mg because the net force in the vertical direction should be 0, and this is weight, right? mg is weight.
Yes, sir.
So if the weight is more, n is more, and if n is more, friction force is more.
Yes, sir.
Friction force mu dn, if you don't know, just accept it. You will learn it later. So basically, the friction force can be increased by increasing the mass, because once the mass increases, weight will increase.
So,
Now, what about reducing the friction force?
so convert sliding friction into rolling friction, ball bearing,
Yeah,
smoothing a surface.
sliding to rolling. This can be done by ball bearings, right?
Yes, sir.
Where is a practical application of ball bearings? Where can you find ball bearings? Practically inside your home.
Uh, I don't know.
In fan, right? Fan is a rotating part,
Yes, sir.
and it's attached to a stationary axis. So the contact between those two, we have ball bearings. Okay, and
Yes.
okay, what else can reduce the? Of course, if you make it smooth, then it
Yes,
will
sir.
reduce. Okay, there is something called lubricants, right?
No. Yes, sir.
So that will basically reduce the roughness effectively.
Yes.
Right. So one way of testing this rolling friction to sliding friction, that will make it more difficult. You know that if you have a chair with the wheels at the bottom, if you lock the wheels and try to move it, it will become more difficult.
Yes, sir.
Right? And also the luggage which you used to uh, drag along, pull. So if that wheel is jammed somehow, then it will be difficult to pull it.
Yes.
Or if you have a bicycle, you can push the bicycle in hand. Okay. Another thing is you apply the brake. With the brake fully pressed, you try to push the bicycle, it will be difficult.
Yes, sir.
I think that will be the most easy way to check this one. Okay. Beat reduce friction. That's what we said. Rolling friction is less than the sliding friction.
Yes, sir.
And that's what is happening here. This person is doing what he's putting the luggage. And here are the wheels. Right? And why do you think rolling friction is smaller than the less than the sliding friction?
So,
Everyone says that, but you have to understand, no, why that is true. So there is a wheel. For example, say tire. Okay. So the sliding friction depends on tire and road surface, right?
yes, sir.
What about rolling friction? Does it depend on tire and the road?
So, yes, sir.
Okay, there is something like axis here, no?
Yes, sir.
And this tire here will be some sort of a disc, right? And the disc is in contact with this axle. The middle point is called axle. Okay,
Yes, sir.
so the disc is made of metal. Okay, and this axis is also made of metal.
Yes, sir.
So when it is trying to roll, it is this friction between this axis and the axle and the disc that is the one that's going to reduce the rotational motion. Okay,
Yes, sir.
and this friction between metal and metal is very small.
So, why, sir?
That is true. You take a brick, okay, and try to drag it along a floor or a mud surface or a concrete surface, and then you take a metal, okay, like a vessel, and on a smooth another metal surface or a glass top and try to push it, you can feel the difference, right?
Yes, sir. Sir, is it because of
Sorry, yeah, it's because of roughness. Metal is a hard thing, so it can be polished smoothly,
Yes, sir.
so that uh, the friction between those two is small. Okay, but tire and all is like there will be a lot of grip in the tire. Even you know the road surface, how rough it is.
Yes, sir.
So when you try to move tire on the road surface without rolling it, it will be difficult. But
Yes, sir.
metal on metal, so the rolling thing is uh, speed. Uh, the resistance to the rolling speed is this contact of the axle with the disc, which is metal contact. This is
Yes, sir.
the axle, and this is the disc. Okay, and the transition motion, the sliding friction is because of the contact between tire and the road surface, where the friction is
Yes.
more. Okay. Right. So far we have uh, talked about surface contact where both the surfaces are solid.
In contact with each other.
Okay. Uh, what about fluid?
Mm.
They have shown an example where the fluid friction is there. So what do you understand by fluid friction?
So the friction between air and water
Okay. It's
object.
between a fluid and a solid.
Yes, sir.
And what is fluid?
So a fluid is air or water. By definition, it should be air and water.
Liquid or gas? Both of them flow. That's why they are combined and they call it as fluid. Okay.
Yes, sir.
Right. So this is the airplane. So does it experience fluid friction?
Yes, sir. It experiences fluid friction between air and it.
Yeah. The air is moving in this direction, right?
Yes, sir.
So the friction force. Okay. Okay. So how come that friction force is overcome?
So by speed.
Huh? The aircraft is moving in the forward direction, right? The velocity is
Yes.
forward direction. So it has to overcome the friction, right?
Yes, sir.
So how does it overcome the friction?
So planes, they use aerodynamics or a streamlined body.
But engine is the one which is driving it, no?
Yes, sir.
Okay. And what is the thing which is keeping floating it in the air? The engine is going
So
to go
pressure
for, yeah. The engine is going to give a forward velocity.
and uplift is by the air itself. The shape of a plane wing allows it to fly.
This is approximately the shape of the wing. And how does it allow it to fly?
So a high pressure air is flown above and low pressure is at the bottom. And this drives the plane to go up.
So the pressure on the wing will act like this, right?
Yes, sir.
So if high pressure is on the top and small pressure is the top, bottom, so the net force is in which direction?
So it should be going down.
But you want it to go up, right? So the force on the top, pressure on the top is less,
Yes, sir.
and the pressure at the bottom is more.
Hmm.
Let me tell you. More force means longer arrow. That's just a way of indicating the magnitude of the force. Okay. So
Yes, sir.
because of it, this will uh, stay afloat. Okay.
Yes.
And why is pressure at the top less?
So because of the shape, it
Okay.
drives more air to the bottom.
Okay. The velocity at the top, say V1, and the velocity at the bottom, that is the velocity of the air, V2. Which one is more, V1 or V2?
So V2.
Okay. V1 is more. Right.
Oh.
Okay. Suppose there are 2 points here, A and B, or hold on. This is A and this is B. And from A to B, I'm going in this direction. Okay. Another one is in this direction. I'm reaching point B at the same time.
Yes,
So
sir.
where will the velocity be more? The upper one or the lower one?
So
Time is same.
lower.
Time is same in both the cases.
Oh,
Time,
so then the
time to go from A to B is same in both the cases. But V1 is taking a longer path and V2 is taking a shorter path. Okay.
yes.
And speed is path length by time, right?
Path length by time.
Yeah, that is distance traveled by time. So distance traveled is more for one or two.
So 1.
So speed is more for one.
Yes, sir.
So V1 is greater than V2. So V1 is greater than V2. And you have this Bernoulli equation, V1 square plus P by rho equal to constant. Okay, so if V is more means pressure will be less. That is why V1 is
Yes,
less
sir.
than V2. And this is the thing which gives the lift to the plane.
Yes.
Same thing the bird is doing. Bird is also shaping its wing like this. So that will also experience an upward force. And this force is called what? There is a special name for this force.
So updraft.
Uh, it's called lift.
Lift.
Lift of an airplane.
Yes, sir.
Right. This is the ball bearing of a fan.
Yes, sir.
Okay, and this ball bearing is here in this top picture. is this part. The one within the middle, this is a ball bearing. Okay. And,
Yes, sir.
and the axis or the axle is in the middle of it. There is contact between the stationary axle and this ball bearing, which is moving.
Yes, sir.
Like this inner part of this ball bearing, it will be stationary. The outer part is going to move. So that, and in between there are balls. So it will be a rolling friction.
Yes, sir.
Okay. Just try to answer this one.
Friction opposes the. So motion.
Relative motion.
Yes, sir.
Okay. Friction depends on the
Smoothness or roughness.
friction produces
Heat.
and wear and tear.
Yes, sir.
Okay. Sprinkling of powder on carom board.
Reduces friction.
Sliding friction is
Less. More than static friction.
actually less. That's a concept. Let me explain it.
So static friction is the friction acting on a moving object.
So this is M, and I'm going to apply a force F. Okay, and the friction force will be in this direction.
Yes, sir.
Let's plot this one. The applied force F here, and then the friction force. When F is 0, what is the value of friction force?
So friction.
Yeah, and the applied force is 0.
So I don't know the exact number.
Okay. See, when the applied force is small, it will be at rest, right?
Yes, sir.
So when it is rest, both the forces should be balanced. F equal to friction. when it's not moving. Okay, so when F is 0, the friction force will be 0. So now when I increase F, the friction force also increase. Okay, I'll keep on increasing, but beyond a certain value, when the force value increases, the friction force will not increase further. It will saturate.
Yes, sir.
So at this until this point, F will be equal to friction force, and there will be any motion. But after that point, F minus friction force will be greater than 0. So there is a net force which will start the motion.
Yes, sir.
Okay. And once it starts moving, the friction force is actually, it will not go like this. It will just reduce a little bit.
Yes, sir.
So just before the motion starts, this maximum friction force, that is static friction, because the thing has not yet started moving. It's still at rest static. But when it starts to move, the friction will reduce a little bit. So this is sliding friction. It started to move, that's sliding. Okay. So static friction is a little bit less than the static friction. This you can experience if you have say a block or a book, heavy book on the table. You slowly try to increase the force to push it, and once it starts moving it, the force that you will require to push will be less. Okay,
Yes,
before the book moves, you will have to apply more force. But once it starts moving, it will become easier to move it.
Yes.
That is because the sliding friction force is less than the static friction.
Yes.
So the sliding friction is less than the static friction. Just hold on. Okay. Second question. Decreasing order. So which friction is more?
So static,
Okay. Next one will be
sliding.
okay. So this one, right?
Yes, sir. It's the only one that's static sliding. I mean, static. Runs her dark car on dry marble floor. With marble floor, newspaper, and friction acting on the car. On different surfaces, increasing order will be. So, first one only, sir.
Force for friction acting on the car. Wet marble floor, dry marble floor, newspaper towel. Yes. First one.
For suppose your writing desk is tilted a little. Book kept on and starts sliding down. So the direction of friction force acting on it. So the direction of friction force is upward. Spill a bucket of soapy water on a marble floor. Would it make it easier or more difficult for you to walk on the floor? So it will become difficult to walk on the floor because the friction between the floor and your feet is now less than it was before when it was dry. So sportsmen use spike shoes to increase grip between the ground and their shoes. Has to push a similar heavier box. The same floor, he will have to apply a large force and why. So SEMA has to apply a large force because weight determines how hard friction acts on a surface or an object.
Now, how is friction force more for a heavier object?
So gravity will be more.
Gravity is same, 9.8, right?
Yes, sir.
I told this one, right? Friction force is due to normal reaction. Okay. Non-normal reaction is m into g. Okay. If the thing is heavier, the normal reaction is more. Yeah.
So why will it become like that?
Because these two forces have to be balanced. No, normal reaction is balancing with weight.
Yes, sir.
And there is no motion in the vertical direction.
Oh,
So it has to be in balance.
yes, sir.
So when you increase the mass, the normal reaction will increase. And when the normal reaction increases, the friction force, which is mu into n, will increase.
Yes, sir.
That is the reason. When the box becomes heavier, normal reaction becomes more, so friction force becomes more.
Yes, sir.
Okay.
So because the force needed to push a static or a non-moving object is harder, but when an object is in motion, it's easier to push it and continue pushing it.
Yeah. So this is the explanation. Why this happens is just the nature of the. But this difference is what that makes it easier.
Yes, sir.
Yeah. What about this one?
So give to the examples friction is both a friend and a foe. So without friction, so we couldn't walk or light up matchsticks. We couldn't stop moving
Yeah.
objects.
And we already seen this one, right? Right. Move to the next one.
Explain why objects moving in front of us. So to reduce friction and allow it to move through the fluid easily.
But there is one more important thing, right? To generate lift,
Yes, sir.
and that lift is created by the pressure imbalance.
Yes, sir.